like it on? I think that's good. Okay, so fold this in thirds just like a letter. What else? So if y'all look at Alicia, she has hers perfectly folded. Right over there, thank you. Richard's all ready to go. He has his paper folded. I see there's a little template of paper on Jarvis's desk. Wonderful Christian. Okay, Carlos and Chris, you need a sheet of paper, computer paper from here. You got it? Oh, I didn't see it. Thank you. Okay, here we go. You can do that way if you want. Oh, well you can do it that way. Maybe that way. And boys, you can do that way too. Just a different way. So, the word that we're going to be doing, that we're learning today, is the Pythagorean theorem. Whoa, that's a long word. Spelling's up here on the board, the Pythagorean theorem. So what I want you to do is write this on the front of your folded sheet of paper, on the very front. Pythagorean theorem, right up here. Today we're going to be going over this word with the BAV, do some practice. And at the very end, we're going to have an exit ticket where I ask you to explain this. Okay, explain the Pythagorean theorem. That's what we're doing the whole day today. We're working on this real long theorem. Or long word, easy theorem. What's that? A pen, that's okay. So Bree's writing this down on her paper. Wonderful. Love it. Alicia's got her pencil out ready to go. Thank you, Trevon, Beyonce, Tiara, Toy, Crystal. Wow, wow, wow. The whole side of the room. I'm going to get rid of a pencil and then we'll give her all some plus points. Here we go. Holy cow. Pythagorean theorem. Okay. Y'all ready? Everyone got their spelling down? No. Set ready to open. On the front page. I'm sorry, what is it? Yeah, just on the front. We're going to talk a little bit about it. So here we go, Pythagorean theorem. Okay. So why is it called the Pythagorean theorem, right? That's a really, really long, kind of confusing word. Why is it called the Pythagorean theorem? So there was a guy in ancient Greece, okay, in 500 AD, who was named Pythagoras, okay? And he studied triangles from the pyramids in ancient Egypt. That's kind of cool, right? So travel to ancient Egypt and study the pyramids. So what shape is one side of the pyramid? What shape is that? Someone raise their hand and tell me. Tara? A triangle, right? And a pyramid is like a three-dimensional triangle. Look at your sheet of paper too, Jeremy. You got it? No, Jeremy?
I gotta go to my Zap class.
Your Zap class right now?
Yeah, they told me to tell you to count the present.
Okay. Okay, so Pythagoras came up with this really cool idea of how to solve for the sides of a right triangle based on studying pyramids. What is a right triangle? We talked about this. Can somebody raise their hand and tell me what's a right triangle? What's special about a right triangle? Jerome?
That was triangle, but one angle at 90 degrees.
Perfect. One angle has 90 degrees, right? One angle is a right angle. Thank you, sir. So he used this theorem, the Pythagorean theorem, especially for right triangles. Triangles have 90 degrees. Let's go ahead and look at this. And here's the theorem. Can somebody read that to me? How would you read this right here? Can I volunteer raise your hand and read it to me? Somebody new? Deviante?
A squared plus B squared equals C squared.
A squared plus B squared equals C squared, right? The little 2 above means squared. So what does that mean? I can read this theorem. If a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Whoa, that's confusing, right? So what that means is that A and B are the lengths of the legs of my triangle. What are the legs of a triangle? We talked about this when we talked about triangle properties. What are the legs of a triangle? Can somebody raise their hand and tell me? The legs specifically, Christian?
The sides is opposite.
The sides opposite the hypotenuse. Perfect. The ones that help create my right angle here. So my legs are my shorter sides, and they're opposite the hypotenuse. Wonderful. And then can someone tell me what my hypotenuse is? The longest side of Brenda, and then what do you say, John? C, right? The longest side, C. Does anyone have any questions on that? Can I feel okay? So if I read this theorem one more time, now that we know what the legs and the hypotenuse are. If a triangle is a right triangle, we know what that is, right? A 90-degree angle. Then the sum of the squares of the length. What does sum mean?
All of them add up.
Plus, right? All of them added together. Perfect. The sum of the squares of the lengths. The squares of the lengths.
Squares are
A and B. I'm sorry, one more time, Brenda?
whatever the squares are added together equals.
There you go. The sum, whatever they're added together, equals the square of the length of the hypotenuse, which is C. Anyone have any questions about that? We just kind of broke down this really complicated, confusing language about Pythagorean theorem into something that's pretty simple, right? You square the two shorter sides, add them together, and it equals the square of the longer side. But yeah, that was easy. Now you can impress people and read that and be like, yeah, I know what that means. Duh, that's easy. Okay, so let's look at an example of baseball then, okay? What shape is a baseball? Any guess? Baseball is diamond.
Quadrilateral.
It's a quadrilateral, perfect. One more time, Antonio. Which,
Like the
sure, yeah, it's baseball diamonds are kind of big.
I don't know. I dropped the basics, but
There, yeah, the part where all the bases are, right? The interior part where all the bases are. A diamond is a square tilted 45 degrees, right? So if you look at a baseball diamond, it's shaped like a diamond, right? But if it's a square that's tilted, how many degrees are created in each angle?
where?
90, right? 90, because 90 is going to be each intersection, right? Where each side crosses. Sound good? Now, if someone said, I'm in a baseball diamond and the distance between each of the bases is 90 feet, okay? So the length between home base or home plate and first base is 90. Between first base and second base is 90 feet, and so on and so forth, right? And then I said, okay, can you tell me the distance between second base and home plate? Could you do that?
Yeah.
Let's go with that. Let me draw this out. Well, pretend that's a beautiful thing. And these are all 90 degrees. Okay? And how long did I say the distance was between each base? 90. And what would we call those? If we were going to use the Pythagorean theorem, what would we call those parts that are 90? I heard it. The legs, right? The legs. It's going to be 90 feet. 90 feet. And someone said, okay, can you tell me what that distance is from second base to home base? Could you do that? Now that if you know what the Pythagorean theorem is, could you do that? Yeah, right? Yeah. What would we call that distance, that diagonal long distance between second base and home plate? Someone raise their hand and tell me. And tell me. The hypotenuse. say correctly. 90 squared plus 90 squared is going to equal what? It's going to equal my c squared, which is my, one more time I tell you? The hypotenuse, right? There you go. Do you have any questions about that? How we plug that in to a real life example?
So,
Oh, go ahead, Joy.
to solve for it, you have to use the square root to solve it.
I would. So what's 90 squared plus 9? Or what's 90 squared? I'm sorry.
180.
180. That's 90 times 2.
Okay.
So square means you multiply by itself, right? 90 times 90. It would be 800.
No, it'd be 8,000.
8,100, right? Because how many zeros are there? It's 90 times 90. You're going to check those 2 zeros on the end, right? So I don't have a lot of things. It'll be 8100 plus 8100 equals c squared. Anyone have a calculator? Can
It'd be
solve it out?
16,200.
Squared. So then would be c squared, right? Equals c squared. And then you could use the square root on your calculator, right? Because I couldn't do that. That's what you know.
That's the answer.
Well, that's my c squared. My c would be what? Use your calculator. Don't try to do it in your head. This is like, ooh, crazy. If you do the square root of this number. Someone in the other class did it, so I just have it in my head already. It's 127.3 is going to be my c. So did you guys know the square root of something is? Right? If my c squared was 25,
It'd be 5.
what would my c be? Right? Because it's 5 times 5. What number times itself is going to give you 25? What number times itself is going to give you 16,200? If you calculate it. But it's about 127. Sound good? Now, someone else also told me that they've played baseball in a field, in a diamond that's 60 feet between each of the bases. What do you think would happen to the hypotenuse? It would change, okay? Can somebody tell me how do you think it would change? If the distance wasn't 90, if it was 60, what do you think would happen to the hypotenuse?
The root, the square root.
The square root would change. Would it be something bigger or smaller?
Small.
Smaller, right? It would be something smaller. Awesome. So do you think it would be easier to play baseball in a field that was 90 feet between each base or 60 feet between each base? I'm not a baseball player, but what do you guys think? 60? So smaller? Have less to run? Yeah. You have any questions on it? Go on. So here are just the questions. What would be our legs? And then what do you think would happen to our hypotenuse if we were referring to a larger baseball field or a smaller baseball field? The hypotenuse would change too, right? The diagonal would be longer and smaller. Okay. So now what I want y'all to do is, on your BAV sheet, write down your definition and draw a picture for our Pythagorean theorem. Oh, I'm sorry, I'll go first. Pythagorean theorem. So, what could you use for your picture? What ideas? What could you use for
A house.
a house? You can find a diagonal of a house, yeah. A right triangle. Perfect. I think you're joking, Tor. I know that. I want you to come up with your own definition. The definition we talked about was really complicated. It's kind of hard to explain. What did we talk about? What's your A and your B and your C? I'm sorry, go ahead, Devin. In a kite? Do you have 90-degree angles in a kite? So if you draw a kite that has 90-degree angles and split across, absolutely, you can do that. You could draw a picture of a baseball diamond, right? Whatever you want. And be sure to have your formula written on your BAV sheet as well. It's wonderful. Lisa's writing this on her sheet. Antonio's drawing a picture. Loved it. Tiara's writing this out. Fabulous. No. I want you to draw a picture of Pythagorean theorem and write your own definition. What do you think? Oh yeah, this is nice. So now,
What are you writing? I'll get your pen. Use a marker for now.
Or actually, do you want to just your definition?
What page can you find it on?
Oh, I don't know if I can tell you that, because I don't want you to copy the definition out of the book.
It's like here.
I want you to do the definition based on what we talked about.
The definition of what?
I just want to see.
Of the Pythagorean theorem.